Imagine yourself sailing through dense fog, where visibility is reduced to a few feet, and landmarks have vanished into the gray mist. Suddenly, a deep booming sound pierces through the obscurity, a foghorn. For over a century, foghorns have guided ships safely through perilous conditions, preventing countless maritime accidents. But how exactly do these mighty instruments work, and what makes their distinctive sound carry through thick fog and across vast distances? In this video, we'll explore the history, mechanics, and science behind foghorns, examining their crucial role in maritime navigation. Let's explore, right here, on History of Simple Things. Foghorns originated out of necessity. Before advanced navigation systems like GPS or radar, ships relied heavily on visual markers such as lighthouses to avoid running aground on rocky shores or colliding with other vessels. However, in heavy fog, these visual cues became useless. Sailors needed an auditory signal that could penetrate the thick mist and alert them to nearby dangers. Enter the foghorn, a device specifically designed to produce loud, low-frequency sounds that could be heard over great distances, even in adverse weather conditions. The invention of the foghorn dates back to the early 19th century, with credit often given to Robert Foulis, a Scottish-born Canadian inventor who developed the first steam-powered foghorn in 1859. Foulis was inspired to create the device after hearing his daughter play piano in thick fog and noticing how lower notes traveled farther than higher ones. The basic principle behind a foghorn is that sound travels differently depending on its frequency and environmental conditions. High-pitched sounds tend to dissipate more quickly in the atmosphere, especially in dense fog or heavy air. Low-pitched sounds, on the other hand, can travel much farther because they have longer wavelengths that are less affected by atmospheric interference. This is why foghorns produce a deep, resonant tone rather than a sharp, high-pitched one. The tone is carefully engineered to carry over long distances, providing an unmistakable warning signal to ships navigating through poor visibility. There are several types of foghorns, but they all work on similar principles. Early foghorns were powered by steam, like Foulis' original design. Steam-powered foghorns worked by forcing steam through a large diaphragm or bell, causing it to vibrate and produce sound waves. The sound emitted was loud enough to travel several miles, ensuring that ships far from shore could hear the signal. Steam foghorns were soon followed by air-powered versions, which used compressed air instead of steam to generate the sound. These air-driven foghorns were more efficient and easier to maintain than their steam-powered predecessors. The compressed air would pass through a vibrating reed or diaphragm, producing the characteristic deep tone of the foghorn. Modern foghorns have evolved significantly from their early steam and air-powered counterparts. Today, most foghorns are powered by electricity, using sophisticated electronic systems to control the sound output. Instead of relying on compressed air or steam, modern foghorns use electromechanical devices or speakers to generate the sound. Some use electronically controlled horns that can vary their tone, duration, and intensity, depending on the specific needs of the maritime environment. These advancements have made foghorns more reliable and easier to operate, while still maintaining the powerful sound needed to alert ships of potential danger. The distinctive sound of a foghorn isn't just about volume, it's also about the frequency and tone. Foghorns are designed to produce low-frequency sounds, typically in the range of 200 to 1000 Hz. This range allows the sound to travel long distances without losing too much energy, making it ideal for cutting through dense fog or other atmospheric conditions that could dampen higher frequencies. The sound of a foghorn is also highly directional, meaning it can be focused toward a specific area, like a busy shipping lane or dangerous stretch of coastline. This directional focus helps ensure that ships receive a clear and strong warning signal, even if they are far from the foghorn's source. In addition to their sound output, foghorns operate in conjunction with other navigational aids like lighthouses, buoys, and radar systems. In some cases, foghorns are mounted directly on lighthouses or other coastal structures, allowing them to provide both auditory and visual signals to passing ships. Many modern foghorns are also automated, meaning they only activate when certain weather conditions like low visibility are detected. Sensors can measure atmospheric conditions and trigger the foghorn when necessary, ensuring that it only operates when needed, conserving energy and minimizing noise pollution in coastal areas. Despite advancements in technology, foghorns still play an essential role in maritime safety. Even though modern ships are equipped with radar, GPS, and other sophisticated navigation systems, these devices can sometimes fail or provide inaccurate information in certain conditions, especially in remote or extreme environments. Foghorns offer a reliable, low-tech solution that doesn't rely on satellites or complex electronics. They serve as a backup system, ensuring that ships can navigate safely even when other systems are compromised. This redundancy is especially important in areas with high shipping traffic, treacherous coastlines, or unpredictable weather conditions. One fascinating aspect of foghorns is their cultural impact. Beyond their practical function, foghorns have become iconic symbols of maritime life. Their deep, melancholic tones are often associated with the sea, evoking feelings of solitude and mystery. Foghorns have appeared in literature, music, and films, where their sound often signifies danger, isolation, or the relentless power of the ocean. This cultural significance adds to their mystique, making them not just an essential tool for navigation, but also a symbol of the seafaring experience. Foghorns are remarkable devices that play a crucial role in maritime safety. From their humble beginnings as steam-powered machines to their modern, electronically controlled counterparts, foghorns have evolved to meet the needs of sailors navigating through dangerous fog and poor visibility. Their ability to produce low-frequency sounds that travel across long distances makes them uniquely suited to alert ships of potential hazards, even in the most challenging conditions. While technology has changed, the fundamental purpose of the foghorn remains the same: to ensure the safety of those at sea. As we continue to rely on advanced navigation systems, foghorns stand as a testament to the ingenuity and practicality of early maritime innovations, reminding us that sometimes the simplest solutions are the most effective. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.